In this section, we're going to learn how to do federated learning with a trusted aggregator, which means that when we actually aggregate our gradients from multiple workers, instead of bringing them to a central server to aggregate them or having them send gradients directly to each other, we're going to have everyone who's involved in the federated learning process or in the federated learning session send all of their gradients to a neutral third party, which we're going to call a secure worker. So first, let's set up PySift. So we've got to do all the normal things we did before. So import Sift, import torch, hook torch, and then import a few other things from torch. And then let's create a few workers. Right, so in this case, we're going to create 3 workers, Bob, Alice, and secure worker. So Bob and Alice are going to be our data owners, and secure worker is going to be this trusted third party that is able to perform the gradient aggregation. Now we're going to do this additional step, which for virtual workers is not strictly speaking necessary. However, for workers in the real world, if you're going to use socket workers or some of these other, HTTP workers, you actually do need to do this. You need to inform workers that other workers exist. So we have Bob, Alice, and secure worker. We're just sort of letting them know that the address, and so have a reference to these other workers. So now we're going to use the same toy data set that we used in the last example, and we're going to train the same sort of simple linear model just to keep everything pretty simple. So that's our data and target. Here's Bob's data, so we'll send it to Bob. Here's Alice's data, which we'll send to Alice. And then we'll initialize a toy model to be the same model that we were working with before, right? So now we're all set up. So we've got our model on our central server. We've got our data set that's distributed. And now let's start working on federated learning. So the first thing we want to do that's a little bit different this time is that instead of just having one model that we send sort of to and from each individual person in synchrony, we actually want to have 2 different models that we send to each of the workers because we want them to be averaged, right? So we'll have Bob's model, which equals model.copy, and we're going to send it to Bob. Then we're going to have Alice's model, which is a copy of the original model, and we're going to send it to Alice. And this also means that we need to have 2 separate optimizers. So we have one for the parameters of Bob's model and one for the parameters in Alice's. So Bob's optimizer equals optim. So this is just standard PyTorch stuff. So it's SGD. Params equals Bob's model.parameters. Running rate equals 0.1. And then Alice's optimizer equals optim stochastic gradient descent params Alice's model.parameters. Running rate equals 0.1. Great. Now, let's do a step of training for Bob's model. So first thing we'll do is Bob's opt 0 grad. So 0 out the gradients. Bob's pred is just going to be Bob's model, Bob's data. As you can see, this is all working with the pointers as it should. Bob's loss. Oops. And then we want to backpropagate. Beautiful. And now we want to do Bob's opt.step. So this does the weight update. And then we'll just kind of get Bob's loss right now. So my O key is not doing what it's supposed to. That is super odd. Okay, I'm going to just copy that for now. Oh, there we go. Okay. And there we go. If we do this multiple times, we can see that Bob's loss goes down. So now we also want to do this separately for Alice. We can just replace all the references to Bob to be references to Alice. Make sure I don't miss any here. Aha. I think it might have been plural. Go ahead and make this plural too. Perfect. And it seems to learn. So now we have this ability to train Bob's and Alice's workers. But now we come to the question of how are we going to average these two models together? So we have Bob's model, we have Alice's model. We trained both of them separately on these different machines, but now I want to be able to average them together. Well, we have this nice convenience method where we can go Alice's model.move secure worker. And what this does, and similar to sort of .send that you might have used previously on the worker, is it just iterates through every parameter in Alice's model and calls .move on that parameter in line. So now we can do Bob's model.move secure worker. And now both Bob and Alice's model are on the secure worker. So if we look at secure worker.objects, we can see here are all the parameters for Bob's and Alice's model. And now all we need to do is just average them together. So if we have Alice's model.weight.data plus Bob's model.weight.data, and we want to average them, so we'll divide them by 2. And then we'll call .get. And then we'll say model, which is our global model, .weight.data.set to be this. Boom. And now we've just averaged our weights. And now we'll do the same thing for bias. So these are the two parameters that we have in linear model. And now we have just averaged our models and brought them back up, brought just the averaged version of the model back up to the central secure server. And so now all we really need to do is just put this whole thing in a big for loop so that we can sort of rinse and repeat, right? So let's see here. We can take this and this and this. And then we move it. And then we average it. So we'll call this for num rounds for rounditor. So one session of this is called a round. This is like a technical term. And this is the number of iterations in the round. And we can actually print Bob and Alice's last loss. And there you have it. Federated learning, where the gradient aggregation happens on a neutral third party. So this makes it so that each sort of layer of additional functionality adds a little bit more privacy and a little bit more flexibility to the different scenarios that we can use federated learning in. So in this case, now we are flexible enough to be able to do federated learning where we work with a secure worker, a third-party aggregator. And actually, this kind of setup is actually the most popular one. So in several large-scale deployments, they actually use sort of a trusted sort of machine that is trusted to sort of aggregate weights together, and then delete what it has sort of left over. I guess we didn't put the delete part in here, but we could certainly do that if we did, secure worker clear objects. Right, there you go. Now secure worker reliably got rid of all of the tensors that it had stored on its machine. So there you go. I hope you've enjoyed this project, and in the next section, we're going to build on this a little bit more.